Most devs use this wrong. Your query is slow because of this. Without an index, scans all 10 million rows, takes 4.2 seconds. With an index, checks only about 23 rows, takes 0.0004 seconds. That's not magic. It's a data structure called a B-tree without an index. A query like select star from users where ID equals 84,213 forces the database to check every single row in order until it finds a match. The complexity here is O of n. It checks all n rows. At 10 million rows, the worst case is 10 million checks. This is exactly why Index's A-B tree is a sorted, self-balancing tree structure. Think of it like the index at the back of a textbook. You don't read page by page, you jump straight to the page. The key property. Every node holds multiple sorted keys, not just two. Real B-trees often store 100 to 200 keys per node, called a page. Why? Because disk reads are expensive. Fewer, fatter nodes mean fewer disk reads. Here's the real mechanism. Say we're looking for ID 84213 in a table of 10 million rows. At the root, one disk read, we compare against 100. And since 84213 is bigger, we go right. At level 2, second disk read, we compare against 84,000 and go right again. At the leaf, third disk read, we find 84,213, 10 million rows found in just 3 disk reads. That's O log n, not O of n. Here's what most people miss. RAM access takes about 100 nanoseconds. An SSD disk read takes about 100,000 nanoseconds. An old HDD disk read can take 10 million nanoseconds. A disk read can be 100,000 times slower than RAM. So B-trees aren't designed to minimize comparisons. They're designed to minimize disk reads. Wide nodes mean fewer levels mean fewer disk reads, and each node maps to exactly one physical disk page. Indexes aren't free. Every insert, update, or delete must also update the index tree. Rebalancing nodes, splitting pages, more indexes means slower writes. Before adding an index, a senior developer checks, is this column actually used in where, join, or order by often? Is the table read heavy, not write heavy? Is the cardinality high, meaning many unique values? And have you actually checked explain analyze first? An index is a sorted B-tree structure. Lookups go from O of n to O log n. Wide nodes exist to minimize disk reads. Every node is roughly one physical disk page. Indexes slow down writes, so use them wisely. This is what powers every fast database in production. Try it yourself. Run explain, analyze on your own queries, and look for index scan versus sequential scan. Follow for more deep tech breakdowns. This is how senior engineers actually think.